This is the review for Section 2 of your Geometry Mid-Year Assessment. Section 2 has 18 questions. This PowerPoint has already been uploaded to your Geometry Microsoft Teams page. You should download it before the exam and use it to study, as well as to help you out on the exam. Ya esta presentación lo subí a la página de Microsoft Teams de la clase y lo deben bajar antes del examen y usarlo para estudiar y para que lo ayude durante el examen. Just like for section 1, I'm including all the rotation, reflection, and translation rules because you need them for some of the problems. You should make sure to look at them before the exam and make sure you understand how to use them. Aquí otra vez tenemos las reglas para transformaciones. Lo deben mirar antes del examen y estar seguro que saben cómo usar estas reglas porque se usan en algunos de los problemas. And also here's a review of the graph of y equals x and y equals negative x in case you need them on any of the problems. Aquí está un repaso del gráfico de la ecuación de y igual a x y y igual a negativo x por si lo necesitan en algunos de los problemas. All right, here's our first problem from our review. It's imitating what's on the test. This is from the last thing that we learned, the last homework that you had, okay? It says determine which of the following relationships is true. Out of these four, there's only one that is true. Okay, letter A says Km is equal to YZ. As you can see, that's not true. Letter B says Km, and by the way, just to refresh your memory, let me draw something real quick. When you have the mid-segment of a triangle, the relationship that exists is that the two lines are parallel. That's what these arrows mean. The two lines are parallel. And I'm going to put a random number here. If this side is 5, if this segment right here, the mid-segment, if it's 5, that means that the bottom line would be 10. It's always double. And by the way, the mid-segment means that it's connecting the midpoint of this side to the midpoint of the other side. That's what these lines mean. It's telling you that this segment equals this segment, so this is exactly in the middle, and the same thing on the other side. Okay, so keep that in mind. Keep that example in mind as we're looking at the answers. So Km does not equal YZ. Does Km equal 2 times YZ? Look at Km. Km is the mid-segment, the line in the middle. All right, does 5 equal 2 times this line? No, because 2 times this line would be 20. 5 does not equal 20. So the first two are wrong. Letter C, Km, remember what that symbol means. That symbol means parallel. Km is parallel to YZ. Yes, that is true. And let's just look at the last one. Letter D, the measure of angle XZY, that's this angle right here. The measure of angle XZY is equal to 2 times the measure of angle XMK, which is this one right here. No, that is not true. So this is a very easy problem. En español, recuerden la relación. Esto es lo último que aprendieron. Cuando tiene este segmento que está uniendo el punto medio de los dos lados del triángulo, la relación que existe es que esta línea es paralela a esta línea. Y estos números, puse números cualquiera para enseñar la relación. La medida del segmento medio siempre es la mitad de este segmento y este segmento siempre es doble de este segmento. Así que si miran la respuesta, la única que es verdadera es la letra C, que te está diciendo que el segmento KM es paralelo al segmento YZ. All right, moving on. All right, this is on the test. A student is doing a common construction. To complete the construction, the student must use a straight edge to connect the endpoint of the ray with the point where the two arcs intersect. The endpoint of the ray, that's right here, with the point where the two arcs intersect, that's right here. So if he connects that, which common construction is the student performing? The common construction that the student is performing is he's copying this angle. He's copying the angle and it's going to give him congruent angles. So if he does what it says there, which is connect the endpoint of the ray to where the two lines intersect, he's going to have an angle that's exactly the same as this angle. He's copying that angle, and it's going to give him congruent angles. That's on the test. Un estudiante está haciendo una construcción común. Para completar la construcción, el estudiante tiene que usar una regla para conectar el punto al final de este rayo a el punto que está formado donde los dos arcos intersectan. ¿Qué construcción es la que el estudiante está haciendo? El estudiante está copiando el ángulo que está aquí arriba, lo está copiando aquí abajo, y el resultado va a ser ángulos congruentes. Esto está en el examen. All right, this is question 3. I mean, it might not be question number 3 on your test because I believe it scrambles the order of the questions, all right? But this is the only one where I didn't have time to make an example that imitates it. All I could tell you is that it's a question similar to question 8 in section 1 that you could look at, but it's easier. Basically, they're going to give you, just to give you an idea what it is, they're going to give you a coordinate plane. Let me switch up where they are, but they're going to give you like a rectangle here and put like rectangle 1 and another one here that says like rectangle 2. They're actually in different locations. I'm trying to disguise it a little bit, but it's going to be like choose all the answers that show how you put rectangle 1 on top of rectangle 2. And it's going to be like translate it 8 units to the right, 7 units down, or do this rotation, or do a reflection and then move it like that. I think that if you have been paying attention to most of the stuff, it's a pretty simple question. And like I said, that's the only one that I didn't have time to make an example imitating it. So there you go. That's the best I could tell you what it's going to be, okay? Esta es la única pregunta que no me dio tiempo a hacer un ejemplo imitando la pregunta, pero le voy a decir básicamente lo que es. Le van a dar 2 rectángulos y tienen que escoger todas las respuestas que correctamente dice las transformaciones que le puede hacer a el 1 para ponerlo encima del 2. Así que van a decir cosas como mueve el rectángulo 1 8 lugares a la derecha y 7 unidades para abajo, y tienen que chequear si eso pone el rectángulo encima del otro. Creo que la pregunta, si han puesto atención, es bastante fácil, pero no me dio tiempo a hacer un ejemplo imitando. Esta era la única que no tuve tiempo de hacer una pregunta, un ejemplo que imita lo que está en el examen. All right, moving on. Question 4. All right, look, the question is up here, and I just put this for reference, okay? But here's the question. Given 2 triangles, if 2 pairs of corresponding sides and 1 pair of corresponding angles are congruent, will the triangles be congruent by side angle side? All right, so you could visualize it. If you got 2 triangles and 2 of the sides in this one are congruent, let me say that better. Two of the sides in this one are congruent to the corresponding sides in this triangle, and one of the angles in this one is congruent to the corresponding angle in this one. Does that mean that yes, they are congruent by side angle side? What do you think? Okay, the answer is not necessarily, because just because they have the 2 sides and the 1 angle doesn't mean it's side angle side, because look over here. In order to be side angle side, it has to be the angle that's in between the 2 sides. Like if you look at the picture, it's this side, the angle in the middle, and then the other side. This side, the angle in the middle, and then the other side. However, we don't have enough information to say that it's this one, because it could also be wait a Oh, my bad. I'm sorry. I confused myself for a second. We don't have enough information to say that it's this one, because we don't know if the angle is in between the 2 sides. All right? We do not know for sure that the angle is in between the 2 sides. So, for example, I could have this. I could have this side is congruent to this side. This side is congruent to this side. And this angle is congruent to this angle. That's not side angle side. With that example, that is not side angle side, because in order to be side angle side, the angle has to be in between the 2 sides. I should have said that from the beginning. I kind of spaced out for a few seconds. Okay, Let me just repeat that in Spanish. En español, si tienen dos triángulos y dos pares de lados correspondientes y un par de ángulos correspondientes son congruentes, los triángulos van a ser congruentes por lado, ángulo, lado. Eso es la pregunta. Te están preguntando que en esa situación, si los triángulos podemos decir que son congruentes por lado, ángulo, lado. Ok, aquí está lado, ángulo, lado. Para hacer lado, ángulo, lado, tiene que ser el lado, el ángulo en el medio, déjame decirlo mejor, dos lados y el ángulo en el medio, congruente a dos lados y el ángulo en el medio. ¿Ok? Así que la respuesta es no necesariamente, porque si miran aquí lo que dibujé, aquí tengo dos triángulos. Este lado es congruente a este lado congruente a este lado, y este ángulo aquí congruente a este ángulo aquí. Para hacer lado, ángulo, lado, el par de ángulos que son congruentes tienen que estar en el medio de los dos lados que son congruentes. No puede, aquí no queda entre estos dos lados. Así, y para hacer lado, ángulo, lado, tiene que estar en el medio de estos dos lados. Así que no necesariamente podemos decir que es congruente por el lado, ángulo, lado. Necesitamos más información. Si el ángulo no queda entre esos dos lados, no podemos decir que son congruentes. Necesitamos más información. All right, question 5. All right, question 5 is another easy one where they're going to give you one of the examples that's here, more or less, one of the examples that's here, and ask you about it. It's another easy question, and I didn't put it basically to try to speed up this whole review, and also because this one's really simple. All right, like if you can't answer it, you deserve to fail. Okay. All right, so it's again, be familiar with all these examples of side, 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 angle, angle, side, and it's a very basic question on it. You should have no problem with it. Okay. Esta pregunta no puse un ejemplo porque es fácil y todo el mundo debe saber cómo hacerlo. Si no lo saben hacer, no merecen pasar el examen. ¿Ok? Pero esto lo puse en la primera parte del repaso. Estén seguros que entienden todos estos ejemplos de lado, lado, lado. Todos estos ejemplos donde te están enseñando dos triángulos que están congruentes por la razón que dice a la izquierda. Este lado, 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 este ángulo, ángulo, lado, este ángulo, lado, ángulo, etc. All right, number 6. Okay, another easy one. I just put make sure you know the following because this is what you need to know to answer the question. It's a simple question. A rigid motion is a transformation that changes the position of a figure without changing the size or shape of the figure. Rigid motions, rigid motions preserve side lengths and angle measures. That means that the side lengths and angle measures stay the same. So if I have a triangle, and I do a rigid motion to it to move it somewhere else, the sides are going to stay the same and the angles are going to stay the same, even if I didn't draw them the same right there. But that's what it means. They're going to stay the same. It preserves the side lengths and the angle measures. And translations, reflections, and rotations are all rigid motions. All right, so any of these, if you do any of these, that's a rigid motion. It keeps the sides and the angles exactly the same in length and measurement, and it does not make it bigger or smaller. The only transformation that we studied that makes it bigger or smaller and is not a rigid motion is dilations. All right, but these three are rigid motions. So make sure you know this because that's what the question is asking you about. And again, you could have my PowerPoint while you're doing the test, so there's no reason to get this one wrong, okay? Para esta pregunta tienen que estar seguros que saben, que entienden las definiciones que escribí aquí. Es una pregunta fácil. Un movimiento rígido es una transformación que cambia la posición de una figura sin cambiar el tamaño o cómo luce la figura. Okay, así que si yo le hago un movimiento rígido a un triángulo, vamos a decir que lo muevo para acá con un movimiento rígido, que lo explico aquí abajo. El tamaño del triángulo es igual, los lados miden igual y los ángulos miden igual. Y eso es lo que dice aquí, que un movimiento rígido preserva el largo de los lados y las medidas de los ángulos. ¿ok? Así que los lados siguen midiendo igual y los ángulos también. Y lo último, estos son tres tipos de movimientos rígidos: una traslación, una reflexión y una rotación. La única transformación que estudiamos que no es un movimiento rígido es una dilatación. Una dilatación hace la figura más grande o más chiquito, pero aquí no te están preguntando de eso. Pero sí tienes que saber que estos tres son ejemplos de movimientos rígidos. All right, here's one where we actually got to do some math. What is the equation of a line perpendicular? Excuse me. What is the equation of a line perpendicular to this line that intersects the line at this point? All right, so reminder, when two lines are perpendicular, their slopes are the opposite sign of each other and the reciprocal of each other. All right, so first of all, let's look at this equation right here. Is this equation in slope-intercept form? Is this equation in slope-intercept form? The answer is yes, it is. The only thing that makes it look a little weird is that it has the y on the right. But if I put the y on the left, like we're used to seeing it, you'll see that yes, it is in slope-intercept form. This is the y-intercept, which we're not going to use right now. And this is the slope, which we are going to use right now. That's the slope, -1. The slope is -1. Okay? So if two lines are parallel, their slopes will be the same. If two lines are perpendicular, their slopes will be the opposite sign of each other and the reciprocal of each other. So the slope of this line is -1. So the slope, which, by the way, if I change it to a fraction, is just that. So the slope of a line perpendicular to it will be just +1 over 1, which is 1. All right? So again, the slope of this line is -1. The slope of a line perpendicular to this line will be +1, because it's got to be the opposite sign and the reciprocal of this number. So the reciprocal of 1 is 1, and the opposite of negative is positive. So the slope of a line perpendicular to that line is going to be +1. Let me just write that. M stands for slope. So the slope of a line perpendicular is going to be +1. Okay, now it says here that it intersects at this line. All right, so that means that this point is on the line. So look what I'm going to do, all right? Let me write this. This is slope-intercept form. Okay, we already know that the slope is +1, but we need to find the y-intercept. I need to find the y-intercept. To find the y-intercept, I'm going to substitute this point for x and y in the equation in order to find the y-intercept. All right, so let me do it. Let me go over here because I'm running out of space. All right, so for y, I'm going to substitute 1.5, and for x, I'm going to substitute -2.5, and this will allow me to solve for b. All right, so when I multiply, I'm going to get 1.5 equals -2.5 plus b. Now to solve for b, I'm going to move -2.5 to the left by adding it to both sides. And I'm going to have, this is going to give me 4. So b equals 4. All right. So we already know that the slope is going to be +1 and the y-intercept is going to be +4. So if I write that in slope-intercept form, it would be that. And of course, you don't write the 1, right? I just wrote it so you could see that it's there. But you don't write the 1. So if you look at the answer choices, it's obvious here that the answer is A. Don't let a problem like this intimidate you. I'm sure a lot of people are going to look at this and be like, it's too complicated. I'll just guess. All right, that's lame. I mean, some of you will do it no matter what because you're going to be lame. Some people are just lame like that. All right, but don't let it intimidate you. That was not difficult, all right? If you want to be good, you got to do some work. Not everything in life is easy. You got to work, all right? Okay, let me just try to say that in Spanish real quick. En español, lo primero que dije es que esta ecuación, bueno, la pregunta dice que es la ecuación de una línea perpendicular a esta línea que intersecta la línea en este punto. Primero que nada, una línea perpendicular a esta línea. Lo primero que enseñé es que esta ecuación ya está en slope-intercept form. Lo único que lo hace lucir extraño es que tienen la y a la derecha y normalmente lo escribimos a la izquierda. Pero si lo escribo aquí, así, se puede ver fácil que el 5e, el y-intercept, que no lo vamos a usar ahora, y el slope e negativo 1, el slope el negativo 1 que está al frente de la x, ¿ok? Y eso es importante porque cuando dos líneas son paralelos, tienen el mismo slope, pero cuando son perpendicular, el slope de la otra línea que es perpendicular es el signo opuesto de este signo y el recíproco del slope de esta línea. Así que el signo opuesto de negativo sería positivo. Y como esto es 1, el recíproco de 1 también es 1. Porque 1, si lo escribimos como una fracción, es eso. Y el recíproco sería la misma cosa. Así que eso es lo que escribí aquí. El slope de la línea perpendicular va a ser positivo 1. Así que aquí está slope-intercept form. Si sustituyo el 1 para el slope, tengo esto. Y ahora me falta encontrar la letra B que representa el y-intercept. Para encontrarlo, sustituí este punto que está en la línea para x y y. Cuando uno sustituye esos números, podemos resolver para B 4. Así que aquí está mi ecuación con el slope y el y-intercept. Cuando E1 no se escribe, así que aquí está mi respuesta. Y igual a x más 4. Alright, moving on. Alright, this one. Basically, listen, one of these examples is on the test with different numbers, but I just put two examples so that I'm not straight up giving you the answer. But look, which transformation was done to these triangles? If you look at them, if you have your rules memorized, it's easy to pick out. And again, you can look at the rules because they're on my PowerPoint while you're doing the test to figure out what's happening here. But let me just put the answer so we can study it a little easier. What's happening in the first one is that the coordinates x and y, they're switching places, and the first, when you put the one in the front, it's changing to the opposite sign. All right, so like the first one was -5, -3. This tells you that the x, you're going to put it in the back. So if you look right here, on the back, they got the same number, -5. And the y, they're putting it in the front, and the negative sign means that they're changing it to the opposite sign. So the y coordinate was -3, they put it in the front, and they changed it to +3. If you look at the other examples, the same thing is happening with all the coordinates. And that rule is a 90-degree counterclockwise rotation. Okay? If you're like, oh, how am I going to know that? How am I going to remember that? Easy. Once you see what's happening, you could just, this is slide number 12. Okay, so once you see what's happening, you could just go right here. Wait, let me make this smaller. You could just go right here to the first, not to the first, but to the rules that I put at the beginning of the PowerPoint and find which one matches up what you see that's happening. All right, these are the rotation rules down here. All right, just find which one matches it up, and right here it says, is it a 90-degree rotation, 270, 180, whatever. Just find what rule is applying, right? Para ese problema pueden mirar aquí en las notas que van a tener para chequear cuál es la regla de lo que explica lo que está pasando con los coordinados. All right? So back to the problem. All right, so and the second one is an example of a 270-degree counterclockwise rotation. All right, that's what this rule is. If you look at these examples, they're getting the xy coordinate, and this is telling you that they're switching places, but this time when you put the x in the back right here, it's changing to the opposite sign. That's what the negative sign means. All right, so the y, you're putting it in the front. So -3, you put it in the front, and it stays the same. But the x, you're putting it in the back and changing it to the opposite sign. So -5, they put it in the back, and it became +5. -8, they put it in the back, and it became +8. -10, they put it in the back, and it became +10. You get what I'm trying to say, right? So whatever, this should be an easy one. All right, there's no reason to get this one wrong. If you get this one wrong, that's just sad. Don't be sad. All right, this one's easy, but I want to point something out because there's a word that we've never used in this class. All right, it says Amanda drew oblique segment AB. That word is on the test, and we haven't seen it the whole year. All right, right here, before I continue with the question, right here I put the definition of oblique. So on the test, please don't ask me what's oblique because I'm not going to answer you. All right, but it's on the PowerPoint. An oblique segment is just a slanted line. That's all it means. They just like to complicate our lives. Why didn't they just write a slanted line or a slanted segment? Anyways, an oblique segment is a slanted line. It is a line that is neither horizontal nor vertical. Again, that word is on the test. This definition, they don't write it on the test. I wrote it here to help you guys out, all right? So back to this. Well, you know what? Let me just say that in Spanish real quick, okay? Dice que Amanda dibujó un segmento oblique. Esta palabra no lo hemos visto en todo el año, okay? Esta palabra está en el examen. Aquí está la definición, pero no, la definición no está en el examen. Lo escribí aquí. Un segmento oblique simplemente es una línea inclinada. Es una línea que no es ni horizontal ni vertical. Es una línea inclinada. Okay? Alright, so Amanda drew oblique segment AB. Okay, this is something that I think is common sense, but maybe some of you don't realize this. When I have a question, a lot of times I'll like sketch out an example and it helps me picture what I'm doing and it makes the question a lot easier. Alright, so let me draw a slanted segment, a slanted line and write AB. You could draw it like whatever. There you go. That's line slanted. Let's put AB. I could have drawn it like this and it's the same thing. It doesn't matter. Alright, but it'll help us picture whatever they're talking about. Amanda drew oblique segment AB on a coordinate grid and translated it 6 units to the right. Alright, so whatever. We don't have, just more or less. 6 units to the right. And let's put A prime, B prime. Which statement must be true? I mean, look, without even looking at it, I mean, it's obviously, just look at the first answer. The segments are parallel. Yes, it's that easy. Don't overthink it. Those two lines are parallel. And that should be obvious. They obviously cannot be perpendicular if you just moved it to the right. How are those going to be perpendicular? Are they on the same line? That also makes no sense. The segments intersect each other but are not perpendicular. A segment begins and ends. It doesn't keep going into infinity. So no, they're not going to intersect each other. All right, this is a no-brainer. This question is easy. If you get it wrong, I should just fail you for the whole year for getting this question wrong. All right, that's an easy one. All right, and again, that word is on the test. Don't be asking me on the test, what does that word mean? Because I'm telling you right now, so study or have the PowerPoint next to you while you're doing it, whatever you want. Okay, esta pregunta es súper fácil. Okay, así que ya sabemos lo que quiere decir oblique. Amanda dibujó un segmento oblique AB en un plano coordinado y lo trasladó 6 unidades a la derecha para formar segmento A', B'. Lo dibujé aquí, algo más o menos para tener una idea cómo luce lo que está diciendo. ¿Cuál declaración tiene que ser verdadero? Ok, la respuesta es que los segmentos tienen que ser paralelos. Eso es bien fácil. No cogen esto mal porque es demasiado fácil. Alright, moving on. Lines J and K are parallel. Line J can be represented by this equation. If line K passes through point 4, -3, write the equation of line K in point slope form. Alright. Right off the bat, I'm sure a lot of you guys are like, oh no, this looks hard. Alright, guys. Be confident, alright? You got this. First of all, you got to know what point slope form is. On the test, they're not going to give you what point slope form is. I'm giving it to you right here on the review, and if you're taking a test and you're like, oh, I don't remember what that is or whatever, look at the PowerPoint. But don't ask me because I'm not going to tell you during the test. Anyways, point slope form is another form for the equation of a line, different from slope-intercept form. This is what it looks like. It's actually not that difficult, all right? We don't use it that much, so it may look strange to you. But all you got to do is this. You put the slope goes right there. You put the slope right there. And for x1 and y1, you put the coordinates of a point that's on the line. Honestly, this is super easy. So give me a chance to explain it and you'll see what I mean. All right, so first of all, the lines are parallel. Line J can be represented by this equation. Okay, remember, when you have parallel lines, their slopes are the same. And I need the slope, all right? I need the slope of the parallel line. So I'm going to use this equation to find the slope. Once I find the slope, it'll be the same slope that I'm going to use in my answer. All right, so 4x plus 5y equals 10. I'm going to rearrange it to put it in slope-intercept form. There's a way to get the slope from this way, from just like that, but I'm not going to do it that way because we've never done that and I don't want to introduce that right now. But so let me just rearrange it so that it's slope-intercept form. To be in slope-intercept form, it's got to look like this. Y equals mx plus b. The y's got to be by itself. So let me move 4x to the right by subtracting it. And that'll give me 5y equals, I cannot combine that, so I'm just going to write negative 4x plus 10. And now I just got to divide by 5. So y equals negative 4 over 5x plus 10 divided by 5, which is 2. But whatever, we're not going to use this part, so it doesn't matter. What we need is the slope. The slope is negative 4 over 5. The slope is negative 4 over 5. Before I continue, let me just let me say that in Spanish so that I don't have to rewrite all this. Okay, así que dice que líneas J y K son paralelos. La línea J se puede representar por esta ecuación. Si la línea K pasa por este punto, escriben la ecuación de línea K usando la forma point slope. Ok, la forma point slope no lo usamos mucho. Es de álgebra 1, pero no es nada difícil. Aquí lo escribí. En el examen no te lo dan, pero recuerden que pueden usar este repaso cuando están haciendo el examen. La forma point slope es fácil, no es nada difícil. Simplemente necesito aquí escribir el slope. Aquí pongo el slope. Y donde está x1 y y1, tengo que sustituir los coordinados de un punto que está en la línea, que voy a usar este punto en un segundo. Así que lo primero que hice es coger esta ecuación y mover los términos para ponerlo en la forma slope-intercept y poder ver que el slope, porque necesito el slope, y el slope de líneas que son paralelos son igual. Así que a la vez que sé el slope de esta línea, va a ser el mismo para el slope de la línea K. Así que cuando moví las piezas y lo puse en esta forma, el slope de esa línea es negativo 4 sobre 5. Que lo escribí aquí, negativo 4 sobre 5. All right, look, I'm almost done. Okay, now let me erase all this because I got too much stuff here. So the slope is negative 4 over 5. The slope is negative 4 over 5. All right, and for x1, y1, I'm just going to substitute this point. The x coordinate, you substitute it for x1, the y coordinate for y1. So when you plug them in, cuando sustituyo estos tres números, when I plug them in, I'm going to have, let me use a different color to make it easier to visualize. I'm going to have this. Y minus, y1 is negative 3, so I'm going to have y minus negative 3. That's where a lot of students mess up. You got to put the two negatives. Aquí es donde muchos hacen un error. It's y minus whatever y1 is, and y1 is a negative number, so y minus negative 3. ¿Ok? E y menos lo que sea y1, y aquí dice que y1 es negativo 3, así que y menos negativo 3. Alright, for the slope I'm going to put negative 4 over 5, parentheses x minus x1 is 4. So I'm almost done. I just need to simplify the two negatives. So my final answer is y plus 3 equals negative 4 over 5, parentheses x minus 4. Okay, ya, ahí está mi respuesta. It's in point slope form. The slope is right here, and the x1 is here, and the y1 is here. That's not really difficult, especially if I'm giving you what the point slope form is. Again, don't let yourself be intimidated by a little problem, all right? If you're going to quit at something so simple, then how far do you think you're going to get in life? Look at that. I'm dropping some philosophy on you. All right, let's move on. Okay, so there's my answer. All right, look at this one now. Samantha wants to prove that the base angles of an isosceles triangle are congruent. She draws isosceles triangle ABC with base angles B and C as shown below. So she wants to prove that the base angles, which are this one and this one. Actually, my bad. Let me keep reading this. Point M is the midpoint of BC. Point M is the midpoint. Well, actually, she wants to prove that angle B is congruent to angle C. And this is an isosceles triangle. So these two sides are congruent. I know those two sides are congruent because it's saying that the base angles are B and C, by the way. So it says, which of the following could be used to prove that angle B is congruent to angle C? Select 3. That's how it says it on the test. Select 3 that apply. So there's 3 correct answers. Okay, letter A. AB is congruent to AC because of the definition of an isosceles triangle. Yes, that one is correct. Letter B. AM is congruent to AM because of the symmetric property. Okay, look at AM is this segment right here. That one is wrong because it's not the symmetric property. That word is wrong. If it would have said the reflexive property, it would have been correct. Remember that I've said several times, and it's come up on several chapters, whenever a segment is congruent to the same segment, the reason is the reflexive property. So they purposely wrote the wrong word there. That one's wrong. Letter C, BM is congruent to CM because of the definition of a midpoint. That's true. BM, if they tell you this is the midpoint, that means that BM is congruent to CM. So that's true. Letter D, triangle ABM is congruent to triangle ACM because of side angle side triangle congruence. Let me think about this one real quick. Okay, no, hold on, give me 1 second. I remember that this is what's tricky about this question is letters D and E. Let me think real quick. Triangle ABM is congruent to triangle ACM because of side angles. Uh, 1 second. Okay, so we said the first one is correct. Sorry about that. I had to pause the recording for 1 second. This one was correct. This one was wrong because it has to be the reflexive property, and it says symmetric. And this one was correct. Okay, so look, the tricky part is these last two answers. D is wrong and E is right. Let me explain why. Okay, first of all, if you follow what we've been proving, it said in the question that this side is congruent to this side. And also, since this is the midpoint, letter C tells us that this side is congruent to this side. And even though letter B is wrong, if it would have said the reflexive property, segment AM is in fact congruent to itself. Okay? So AM is congruent to AM in both triangles. So if you look at what we've proven congruent, it's side, 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 side. And letter D is saying side, angle, side. So letter D is wrong because we have not yet proven that angle B is congruent to angle C. But we've proven that we've proven that the three sides are congruent in both triangles. So the reason the two triangles are congruent is because of side, side, side. Now, once you've proven that the two triangles are congruent, then angle B is congruent to angle C because corresponding parts of congruent triangles are congruent. Let me say that another way. Let me explain it another way in case anybody's a little lost. Imagine that we're doing a proof. Imagine that we're doing a proof here to prove that angle B equals angle C. You cannot say that triangle ABM is congruent to triangle ACM because of SAS if we have not yet proven that angle B is congruent to angle C. Because when you say SAS, you're saying you're talking about this angle right here, that side angle side is congruent to side angle side in the other triangle. But we have not yet proven that this angle is congruent to this one, so you can't use that reason in your proof. However, you can use, if this would have said side, 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 like with an S in the middle, side, 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 then that would have been correct. Because that's what they've proven in this proof. If you go in order, they've proven that this side equals this side equals this side. And even though the reasoning is wrong, the side that they both have in common is congruent to itself. So if it would have said side, 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 it would have been correct. So if you were doing a proof here, the last reason that you would put is that angle B is congruent to angle C because corresponding parts of congruent triangles are congruent. And the reason that comes before it would have been SSS. They just wrote it wrong. They wrote side, angle, side. I hope that makes sense. Okay, let me say that in Spanish. en español. Samantha quiere comprobar que los ángulos de la base de este triángulo isósceles son congruentes. Ella dibuja este triángulo ABC con los ángulos de la base B y C. Ok, así que si los ángulos de la base es B y C, eso quiere decir que este lado es congruente a este lado porque en un triángulo isósceles. Ahora te dicen que el punto M es el punto en el medio de BC. Tenemos que seleccionar 3 razones que se pueden usar para comprobar que ángulo B es congruente a ángulo C. La letra A, AB es congruente a AC por la definición de un triángulo isósceles. Sí. Letra B, AM congruente a AM por la propiedad simétrica. No, eso está mal. Debe ser la propiedad reflexiva. Así que por esa razón esta letra está mal. Letra C, BM congruente a CM por la definición de un punto medio. Sí, eso está correcto. Ok, la letra D está mal porque dice que el triángulo ABM es congruente al triángulo ACM por lado, ángulo, lado. Y no, lo que han comprobado es que son congruentes por lado, lado y este lado que los dos tienen en común. Así que debe decir lado, lado, lado. Pero escribieron lado, ángulo, lado, así que eso está mal. Y el último está correcto porque a la vez que se enseña que los dos triángulos son congruentes por lado, 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 entonces eso no deja de decir que ángulo B es congruente a ángulo C por esta razón. La parte correspondiente de triángulos congruentes, déjame decirlo otra vez, las partes correspondientes de triángulos congruentes son congruentes. All right, next one. All right, the triangle with vertices at these points is translated 5 units to the left and then 4 units up and then reflected over the line y equals 2 to form the image L prime, E prime, D prime. Which vertex of the image is the greatest distance from the origin? All right, look, the way I wrote it, I think makes it the easiest to understand what to do in this question. This question is on the test, except instead it's similar, like everything they're going to ask you to do is similar to what I wrote here, but the numbers are going to be a little bit different. However, the way I wrote it really, I think, makes the question a lot easier to understand. You need to look at this before the test and make sure you understand it step by step because there's another one like this coming up in a second. All right, so it says, first thing you got to do is translate it 5 units to the left and 4 units up. So remember that when you move something to the left, when you move it left or right, that's controlled by the x-axis. If you move it to the left, you subtract by 5. If it would have been to the right, I would have added by 5. And up and down is controlled by the y-coordinate. So if you move it 4 units up, you got to add 4 to the y-coordinate. If it would have been down, I would have subtracted 4. Let me say that in Spanish real quick before I get to the last part. Ok, así que te están dando... Hay esta pregunta y otra que viene similar a este. Así que creo que la manera que escribir los pasos, esto es la manera más fácil de entender cómo hacer este problema. Ok, así que te están dando al principio los vértices de la figura y le tenemos que hacer dos transformaciones. La primera es trasladarlo 5 unidades para la izquierda y 4 unidades para arriba. Recuerden que el coordinado de X controla el movimiento derecha e izquierda, así que si se mueve para la izquierda 5 unidades, se tiene que restar 5 al coordinado de X. Si hubiera sido para la derecha, se suma 5. Y el coordinado de Y controla el movimiento para arriba y para abajo. Así que si se mueve para arriba 4 unidades, tengo que sumar 4 al coordinado de Y. Si hubiera sido para abajo, tendría que restar 4. Alright, so that gives me these new coordinates. Eso me dan estos coordinados. Alright, now the last one is reflect over the line y equals 2. Okay, so picture this a second. The line y equals 2 is right here. If you don't know why it's right here, look, I explained it in section 1 of the review. I'm not going to re-explain it right now. Ok, aquí está la línea y igual a 2. Si no saben por qué está ahí, lo expliqué en sección 1 del repaso. Alright, so if you got a shape, like, you know what? Not even a shape. Let's just put a random point. Let's use this point right here. Although, it's on the other side. Fine, let me... Forget that. Let me put it over here. All right, so this point is at -8, +10. All right, I'm just going to do the example with this point. Lo voy a explicar usando solamente este punto aquí. All right, L prime, -8, +10. You know what? I'm sorry, but let me draw it a little bit better because with more space. Déjame dibujarlo mejor. All right. So here's what I want you to picture. If you're gonna reflect over y equals 2. If I'm gonna reflect this point over the line y equals 2, it's gonna be somewhere over here. Let's put L double prime. Is the x coordinate gonna change when I reflect that over the line y equals 2? No, the x coordinate is gonna stay exactly the same. Now, what is the y coordinate gonna change to? Okay, the y is at +10. +10 is located 8 units. I don't mean to make it confusing. I didn't realize it's gonna have the same number that's there, but +10 is located 8 units above y equals 2. Because here's y equals 2. If you go 8 units above, you're at y equals 10. All right, so you got to put it 8 units below y equals 2. All right, how do I put it 8 units below y equals 2? I subtract 8 from the number 2. So 2 minus 8 will give me -6, which is what I have here. You would follow the same process for all 3 points to get their new location. Again, the x-coordinate, when you're here, the x-coordinate stays the same. Notice that the x-coordinate stayed the same. It's only the y-coordinate that's being affected when you reflect it over y equals 2. It's not that hard, especially the way that I wrote it. Again, on the exam, it's going to be extremely similar to this, except this is going to be just slightly different. And you're going to reflect it over y equals a different number than 2. So if you understand how to do this one, you'll understand how to do it on a test, all right? En español. Así que aquí tengo el punto L', ¿ok? Si yo reflejo ese punto sobre la línea y igual a 2, el coordinado de x no cambia, se queda igual. Todavía va a estar en el mismo lugar que corresponde al coordinado de x, -8. Lo único que cambia es el coordinado de y. Así que tienen que imaginar si este punto está en la línea donde y es 10 y lo vamos a reflejar sobre la línea donde y es igual a 2, 10 está 8 unidades arriba de 2. Así que si lo reflejo sobre la línea y igual a 2, tiene que estar 8 unidades debajo de esta línea. Así que tengo que hacer 2 menos 8 para ponerlo 8 unidades debajo, que sería -6. En todos estos ejemplos, cuando se refleja sobre la línea y igual a 2, si se fijan, el coordinado de x no cambia, se queda igual. Solamente está afectando el coordinado de y. El problema en el examen es bien similar a lo que yo escribí aquí. La única diferencia va a ser que los números van a ser un poquito diferentes y lo van a reflejar sobre y igual a un número diferente de 2. Pero si entienden cómo hacerlo en este ejemplo, lo van a entender cómo hacer en el examen. All right, number 13. Make sure you understand this proof. All right, look at this proof before the exam because you need to know it for the test. Let me move on because this review is already, just like the other one, pretty long. Okay. Tienen que saber esta prueba para el examen, porque lo necesitan saber, all right? All right, number 14. Triangle MNO is congruent to triangle PQR. Determine the length of QR. Here's QR. All right, here's the issue with this problem. When you look at QR, they got two variables. All right, so let me tell you the trick to solving this problem. If these two triangles are congruent, you first got to put, I'm going to use colors. You first got to put this side equal to this side in order to solve for whatever x is. And then to find out what y is, you got to make this side right here, because it says 2y plus 3, equal to this side to solve for y. Once you do both of those, you'll know what x equals and what y equals, and you can plug them in right here, which I'll show you in a second. All right, let me say it in Spanish. El problema, la pregunta dice que los dos triángulos son congruentes. Tenemos que determinar el largo de QR de este lado. El problema es que en este problema hay dos variables, X y Y. Así que miren a los colores. Para hacer este problema, primero tengo que poner este lado, el rojo, igual a este lado, en una ecuación para resolver para X. Let me see if I put this in. Yeah, so that's what I did right here. I made 4x minus 2 equal to 18, and that allowed me to figure out what x equals. Okay, eso es lo que hice aquí, y eso me deja resolver para x, x es igual a 5. Now look at the blue sides, miren los lados azules. Como este lado tiene y, lo pongo igual a este lado, y eso me deja resolver para y. Alright, when I do the same thing with these two sides, put 2y plus 3 equal to 25, it allows me to solve for y. And once you know what x and y equals, the last step is to plug them in right here and add them up, and that gives you the answer. A la vez que uno sabe el valor de x y y, simplemente sustituirlo aquí, y eso nos da la respuesta. This is on the test. I just changed the numbers, but this question is on the test. Esta pregunta está en el examen, yo simplemente le cambié los números. All right. All right, guys, number 15. I'm getting tired. All right, okay, so this picture is exactly from the test. I just changed the values of each angle, but this is on the test. We got to find out what's the measure of angle 2. Esta foto, este diagrama está en el examen. Yo simplemente le cambié el valor de cada ángulo. All right, so since I'm running out of gas here, let me show the answer so I can explain it a little easier. All right, so 3y plus 6. Okay, so the first thing I did is, if you look at the solution, I should have put on the top this. Let me write it here. The measure of angle 3 is equal to the measure of angle 4. All right. So I should have written that at the top. Why are they equal? Because look, if you look at the picture, it tells you that L is parallel to M. These two lines are parallel. These two lines, line L and line M, are parallel. And you got this line, which is a transversal. So angle 3 and angle 4 are corresponding angles. So they got to be congruent. All right. Ángulo 3 y ángulo 4 son ángulos correspondientes, así que son congruentes. Y eso es lo que dice aquí. Ángulo 3 es igual a ángulo 4, así que sustituí lo que dice aquí y aquí para resolver para Y. I substituted what it says for the measure of angle 3 and the measure of angle 4 in order to solve for Y. Okay, once I figured that out, that Y equals 30, that allowed me to plug it in. All right. Once I figured out that y equals 30 right here, that allowed me to plug it into to both of these. Once you plug that into both of these, you're going to get that angle 3 equals 96 degrees and angle 4 equals 96 degrees. Okay, a la vez que encontré el valor de y, que es 30, lo sustituí aquí y aquí para saber que la medida de ángulo 3 y la medida de ángulo 4, los dos son 96 grados. All right, so this is 96 degrees, and this is 96 degrees. All right, what did I do next? All right, the next thing I did is basically the same thing, but with angle 1 and angle 5. Let me use a different color because it's getting a little messy. Okay, angle 1 and angle 5. Okay, it may be hard to see, but when you have these two parallel lines and this transversal, sorry. Angle 1 is alternate exterior angle with angle 5. Angle 1 and angle 5 are alternate exterior angles, which means that they are congruent. Angle 1 and angle 5 are alternate exterior angles. So that's what I did here. Again, this work is from last year, so my bad for not writing this. And the way I did this, I can't like just go in and write over it. Or I could, but I'm not going to do that right now. Sorry. Así que ángulo 1 y ángulo 5 son alternate exterior angles. Ángulos exteriores de lados alternos de este transversal. Y cuando esa relación existe, esos dos ángulos son congruentes. Por eso es que puse aquí que ángulo 1 es igual a ángulo 5. Sustituye x más 12 igual a 5x menos 20. That allowed me to solve for x equals 8. And once you know what x equals, you can plug it in here and in the bottom one to find that the measure. This is so much work, man. The measure of angle 1 equals 20 degrees, and the measure of angle 5 equals 20 degrees, all right? So, and we're still not, I mean, I know the answer's there, but you have to do all that work. And so we figured out that this is 96, this is 96, this is 20 degrees, and this is 20 degrees. And after you do all that, hold on, I should be able to. Oh, all right. This problem is a lot of work. All right, I haven't done this since last year, and I'm just remembering what we got to do next. Okay, so look, in order to find the final answer, because I just put, when you plug in these angle measures, you should be able to figure out that the measure of angle 2 is 76. Okay, look. If this angle right here is 20 degrees, that means this one right here. Now let's look at this triangle here in the middle. With everything that we found out, let's look at this triangle in the middle. If this one is 20 degrees, that means this one is 20 degrees. That says 20, I know it's hard to see, okay? Vamos a enfocarnos en este triángulo aquí. Si este ángulo mide 20 grados, este también es 20 grados porque son ángulos verticales. All right, these are vertical angles, so they gotta equal the same. Okay, now this angle is a linear pair with this angle. That means together they add up to 180. So to find this one right here, I just do 180 minus 96, and that's gonna give me 10. Wait, I don't want to make a mistake. It's very late, and I can barely think right now. It's late now that when I'm recording this video, I mean. All right. Yeah, I just want to make sure I don't make a dumb mistake. All right. So these two angles are linear pairs, so that means that this angle right here is 84 degrees, okay? Estos dos ángulos es una pareja lineal, así que la suma te tiene que dar 180. Si este es 96, para encontrar el que falta, tengo que hacer 180 menos 96, que me da 84. And then last step, when you add up all the angles in a triangle, it always equals 180. La suma de todos los ángulos de un triángulo siempre te da 180. So 180 minus this 20 degree angle is 160. Primero le resto este ángulo de 20 grados, así que me queda 160. And 160 minus 84 gives me my answer, which is 76 degrees. All right, moving on. Almost there, guys. All right, number 16 here, another tough one. All right, look. It says which series of transformations, I messed it up here and I put this picture. All right, that I could fix really fast. Let me fix that. All right, there we go. Let me save it. All right. Which series of transformations could be used to prove that triangle A prime, B prime, C prime is congruent to triangle ABC as shown in the graphs below? In other words, which one of these will put this triangle on top of this triangle? Básicamente, ¿cuál de estas transformaciones te pone este triángulo encima de este triángulo? All right, listen. There's the answer, and the explanation is on the next slide. So let's go to the explanation. You basically got to check all these out to see which one will put ABC, which one will put these coordinates on top of these coordinates. Yeah, this requires some work. What can I tell you? As you'll see on the next slide. Okay, tienen que chequear las diferentes respuestas para ver cuál pone este triángulo encima de este triángulo. All right, so right here is the main part. The blue part is the main part you got to look at. This drawing, I put it just to give you a visual aid. Okay, la parte más importante para mirar es la parte aquí en azul. Esto lo puse para que puedan ver lo que está pasando con los triángulos. All right, so the pre-image is the blue triangle. These are the coordinates they gave me. And the correct answer said to first reflect it over y equals x. If you recall, y equals x is this diagonal line that goes like that. Y equals x is the line that goes like that. So when you reflect it over y equals x, this is the rule. xy becomes yx, and that's what I did here. and then reflect it over segment A prime, C prime. All right, so when I did this one, I got the pink triangle, and then if you reflect it over this side, A prime, C prime, you're going to get my final answer, which is the red triangle, and it has these coordinates. Guys, yeah, this one, I don't know if it's because I'm tired right now when I'm recording this, but yeah, this one, what can I say? Some of these, you gotta work it out. Some of you are going to do it, and some of you are going to be like, nah, forget it. That's too much work. And you get out of it what you put into it, all right? Out of the class, out of life, out of everything. You get out of it what you put into it. If you think this is too much work and it's not worth your trouble, you're probably someone that usually ends up with F's or D's. All right? You get out of it what you put into it. The people that are like, yeah, this is annoying, but I'm gonna do it anyways. Those are the people that end up with A's and B's. Just like me, I'm here late at night, putting in the work, doing this review for you guys. Other teachers will be like, nah, forget it. They'll figure it out, and I'll just put F's. All right, it's you get out of it like whatever you put into it. All right, that goes for everything in life. Okay, así que aquí en azul está la explicación de todo lo que las transformaciones que le estoy haciendo al triángulo. Sí, es un poco de trabajo este problema. Si quieren mejorar, tienen que poner trabajo. Y si no le importa tanto, van a terminar con F o D. Es la decisión de ustedes. All right, moving on. I'm not too good at philosophy in Spanish. All right, we're almost done, guys. Two more. Guys, I'm trying to. I sound like I'm trying to psych you up, but secretly, low key, I'm really trying to psych myself up to finish this. All right, question 17 of 18. I hate how I've taken on slang from you guys, low key. Not when I say you guys, I mean students in general. All right, I say these things. I would never say them around other adults because they'd be like, low key, what? All right, moving on. Okay, so look, this question is simple, but they make it a little bit confusing. All right, it says if JL equals 10, all right, JL equals 10, and KM equals 7x minus 2, and KM is the perpendicular bisector of JL, find the length of each side along with the perimeter. Find the length of each side along with the perimeter. All right, so let me see. Do I have this? Yeah. All right. If KJ, sorry, I'm just reading what I wrote here. I may have to check something real quick. Just 1 second. All right, guys, I want to point out something important. If that's easy to overlook on this question. Hold on, let me. All right, here's a key thing in this problem that's easy to overlook. If KM is the perpendicular bisector of JL, okay, you may have forgotten this, but when you have the perpendicular bisector, that means that it's perpendicular and that there was a theorem or a rule or whatever you want to call it, that any point that I put on the perpendicular bisector has to be equidistant from the two endpoints. So if KM is the perpendicular bisector, if KM is the perpendicular bisector of segment JL, that means point K has to be equidistant to point J and point L. That's important because that allows me to say that this side has to equal this side, which is what I did to start the problem. I made this side equal to the other side, and that allowed me to solve for x. All right, let me just say that in Spanish real quick before I continue. Okay, si KM es el bisector perpendicular de JL, que lo hice en la pregunta, okay, había una regla que aprendimos que un punto en cualquier lugar en el bisector perpendicular de un segmento tiene que ser equidistante, tiene que estar a la misma distancia, ese punto está a la misma distancia de los dos puntos al final. Así que si KM es el bisector perpendicular del segmento JL, eso quiere decir que donde quiera que yo ponga un punto en este segmento, la distancia desde este punto hasta J y hasta L tiene que ser igual. Eso es importante porque me deja decir, o saber que la distancia desde el punto K hasta J y hasta L tiene que ser igual. Eso quiere decir que el lado JK es igual, es congruente al lado LK, que es como empecé el problema. KJ igual a KL. Y eso me deja resolver para X. A la vez que sé el valor de X, lo puedo sustituir aquí y aquí para saber el largo de estos lados. Alright, once I know what X equals, I can plug it in right here and right here as well. They're both going to give you the same answer to find out how long both of these sides are. So, which is what I did here. KJ is 13 and KL is 13. Okay, what else? Okay, now it said to find the perimeter. You got to find the perimeter. And at the beginning of the question, they told you that JL equals 10 at the beginning of the question. So JL is 10, and I was able to figure out that these two sides are 13 and 13. All right, so to find a perimeter, I just added all three sides and got my perimeter. All right, I want to point something out. And listen, I'm imitating here what's on the test. What I want to point out is this. They gave you what KM equals. And also, notice that it's very similar to what it says over here. But they gave you what KM equals, and I did not use that on the entire question. It's like that on the test. That's in there to throw you off, I guess. Because we don't actually use that to... or at least if there's a reason for that, I don't know what... like I said, it's late. Right? If I remember correctly, there's no use for that. All right, so you don't use that at all to find your answer. All right, and there's your answer. I'm about to wrap this up. Let me just say this in Spanish, and then we got one more, and I'm done. Okay, so en la pregunta nos dijeron que el segmento JL mide 10 y ya pude encontrar que cada de estos lados es 13. Ahora tenemos que encontrar el perímetro del triángulo. Para encontrar el perímetro, eso es la distancia alrededor del triángulo. Simplemente se suma los tres lados, que es lo que hice aquí y me dio 36. Lo que estaba explicando es que esta información que nos dieron, que KM igual a 7x menos 2, eso no se usó en el problema. ¿Ok? Así que simplemente porque te dan algo en el problema no quiere decir que lo tenemos que usar. Y esto está imitando cómo está la pregunta en el examen. All right. Last thing is this. There is a question with several correct answers. All right. There's a question where they're going to tell you that a student is trying to construct a square inscribed within a circle. If you're not sure what that means, look at the last step. That's what that means. A square inside of a circle. That's basically what they're doing. Here are the steps to do that construction. All right. The question is going to be asking you. It's going to give you like four multiple choice possibilities, and you got to check yes or no for each one. It has several correct answers. All right. It's going to ask you, it's going to give you these different, like four different reasons, and you got to put, are those one of the steps that you could use to put this square inside of a circle? So listen, these constructions, we haven't really done them that much. So this is what I advise you to do. What I advise you to do is have the PowerPoint with you while you're taking the test, because you downloaded the PowerPoint in advance, like Mr. Yu taught you to, or told you to, hopefully. And just read the different answers and check, is that one of the steps you could take to do this? And that's how you answer the question. What you need for this question is reading comprehension, which maybe... which is asking a lot from some of you, because some of you guys don't read that much, okay? I know this by the way, I know this not from any of you guys, but just from years of teaching and always being surprised at how poor reading comprehension is with a lot of students. All right, so here are the steps. You just got to check the different answers and check, is this one of the steps needed to do this? It's not difficult. I'm basically giving you the answer. You got to check, are the steps here when you're doing the test, all right? Para la última pregunta, en el examen le van a decir que un estudiante está construyendo un cuadrado dentro de un círculo, que es lo que está aquí en la última foto. ¿ok? Aquí están los pasos para hacer eso, porque eso no lo hemos practicado ni no lo estudiamos casi nada, ¿ok? La pregunta va a tener como 4 o 5 opciones. Tiene varias de las respuestas, varias de las opciones están correctas. Hay más de una respuesta correcta, ¿ok? Así que te voy a poner las opciones y decir, chequeen cada opción y tienen que decir sí o no si eso es un paso que se usa para hacer esto. ¿Ok? Así que tienen que leer y mirar aquí. Recomiendo que bajen esta presentación antes del día del examen y que lo tengan abierto en lo que están haciendo el examen y chequear aquí para ver si lo que dice en el examen es uno de los pasos que se usa. Alright, así que simplemente tienen que leer y escoger correctamente. Alright, guys, if I'm not mistaken, I think that's it. Yeah, that's the end of the review for section 2. Again, make sure to download all the PowerPoints from the Microsoft Teams webpage before the day of the test. If on the day of the test Microsoft Teams is down, guess what? That's your problem because for not following my advice. All right, download it way in advance and make sure you have it with you. I would study as much of it as possible before the test. If you wait till the day of the test to try to look at this and try to figure it out, good luck. I'm sure you're going to do awesome. You're going to be all stressed out and you're going to do horrible. And you're going to end up guessing on most of them and getting a horrible grade. And I'm going to count the test a lot. All right? I'm going to count the test a lot. You've been warned. So I would look through it and make sure you're familiar with most of it. If on the day of the test, if during the test you got to look up a few things, that's fine with me. But make sure you're familiar with like 80% of it, in my opinion. Alright, and so otra vez recomiendo que todo el mundo baje las presentaciones para sección 1 y 2 antes del examen. Porque si el día del examen Microsoft Teams no está trabajando o hay un problema, eso no es mi problema, eso es el problema de ustedes. ¿Ok? Deben estudiar esto antes del examen y por lo menos entender, yo diría 70 o 80% del examen. Si tienen que chequear algunas cosas durante el examen, eso está bien. Pero no esperen hasta el examen para tratar de entender esto porque no lo van a poder hacer. Es demasiada información y hay muchos problemas que son un poco complicados. All right? All right, guys, so that's the end of this review. Hope you guys have a great rest of your day. And the test is next class. The next 2 classes are the exams, so make sure to study. Las próximas 2 clases se va a hacer el examen, así que estudien. Las próximas 2 clases tienen el examen. All right, have a great rest of your day, and I'll see you guys next class.